Welcome to the Running Library. Quick, practical ideas to think clearer and live better. Today, we're breaking down Weapons of Math Destruction by Kathy O'Neill. Let's keep this practical. And let's start with the strongest idea first. A lot of the biggest decisions in your life are being made by math you can't see. And the scary part is, the math is often wrong in ways that hurt the same people over and over. Weapons of Math Destruction is Kathy O'Neill's warning label for the algorithmic age. It's not an anti technology book, it's a book about what happens when we hand power to models that are opaque, unaccountable, and scaled to millions of lives. O'Neill calls these systems weapons of math destruction, WMDs, not because they're made of code, but because of what they do. They can punish the poor, reward the already powerful, and make inequality feel objective. Let's break down the biggest ideas, and then I'll give you a practical action plan for spotting these systems in the wild. Big idea number one. The most dangerous models share three traits: opacity, scale, and damage. A model becomes a weapon when you can't see how it works, when it affects huge numbers of people, and when the consequences are real, like losing a job or getting denied a loan or being targeted by police. Why it matters: because these models don't just predict the world, they shape it. And when they're wrong, they can keep being wrong forever because nobody can challenge them. Action step. When you hear the algorithm decided, ask three questions. Can I inspect it or appeal it? How many people does it affect? What's the downside if it's wrong? If the answers are no, millions, and a lot, you may be looking at a WMD. But here's where it gets interesting. Big idea number two. Many models don't measure what they claim to measure. They use proxies. A proxy is a stand-in. It's when you can't measure the thing you actually care about, so you measure something nearby and then you pretend it's the same thing. Why it matters: because proxies can smuggle in bias while looking neutral. A classic example in the book is employment screening. Companies want good employees, but good employee is hard to measure. So a model might use things like credit history, zip code, or gaps in employment as a proxy. Those signals often correlate with poverty, not with performance. Action step. Anytime you see a score, ask, what is this actually measuring? And what is it using as a proxy? If the proxy is something like neighborhood, debt, or prior risk labels, be skeptical. Now, here's the mistake most people make. They assume that if a system uses math, it must be fair. Big idea number three. Feedback loops turn predictions into self-fulfilling prophecies. A model makes a prediction. Then institutions act on that prediction, and their actions create data that proves the model was right, even if it wasn't. Why it matters: because once a feedback loop starts, it can trap communities. O'Neill talks about predictive policing as a key example. If police are sent more often to certain neighborhoods because a model labels them high risk, then more arrests happen there. Not necessarily more crime, more detection. That new arrest data goes back into the system, and the model says, see, I was right. The loop tightens. Action step. When you hear about prediction systems in policing, hiring, lending, or education, look for the loop. Ask, does the model's output influence the data it later learns from? If yes, demand safeguards, independent audits, and measures of real outcomes, not just more hits. This is the part most people skip. Big idea number four. Optimization can quietly destroy the mission. Models optimize for what you can count, not for what you value. And what you can count is often a narrow slice of reality. Why it matters: because once you attach rewards and punishments to a metric, people will game it, or they'll be crushed by it. O'Neill highlights how performance metrics can warp institutions. In education, for example, if teachers and schools are judged heavily by test scores, the system pressures them to teach to the test. It can punish schools serving high-need students, and it can label teachers as bad based on shaky statistical methods, even if they're doing heroic work. Action step. In your workplace or your community, list the top 2 metrics being used to judge success. Then ask, what important things do these metrics ignore? If the metric is easy to game or disconnected from the true mission, push for a balanced scorecard. Mix quantitative metrics with qualitative review and use longer time horizons. But here's where it gets personal. Big idea number 5. These systems often punish people who have the least ability to fight back. O'Neill's point is not just that models can be wrong, it's that the harm is uneven. Wealthy and powerful people get the benefit of human attention. They get exceptions, they get appeals, they get lawyers. Everyone else gets an automated no. Why it matters? Because inequality becomes automated and it becomes invisible. A denied loan, a rejected job application, a higher insurance rate, a high risk label. Each one might feel like an isolated event, but at scale, it's a machine. Action step. If you're dealing with a high stakes decision, don't treat it as a one shot application. Build optionality. Apply to multiple places. Ask for reconsideration processes. Document everything. And whenever possible, route your case to a human. Now, a quick mini reset. We've talked about opacity, proxies, feedback loops, and warped incentives. And in a moment, I'll share the most powerful principle in the entire book, the question that reveals whether a model is helping society or quietly harming it. Big idea number 6. The most powerful principle: demand accountability through outcomes, not just intent. A model can be built with good intentions. That doesn't matter. What matters is what it does in the real world, and whether someone is responsible when it causes harm. Why it matters, because we didn't mean to is the default excuse of harmful systems. The model was trained on historical data. The data reflects historical injustice. The model repeats it. And then the institution shrugs and says, it's just the numbers. O'Neill argues that models should be tested like other high-impact systems. They should be monitored, audited, and adjusted when they produce unfair outcomes. Action step. When you encounter an algorithmic decision in a high-stakes context, ask one question. What outcome are you monitoring to prove this system is working fairly? If the answer is vague or proprietary or we don't track that, that's a red flag. Because accountability starts with measurement of harm, not just measurement of efficiency. But here's where it gets even more useful. O'Neill isn't saying ban all models. She's saying treat models as tools, and tools need safety standards. So let's turn the book into a practical action plan. Practical action plan: how to spot and respond to a weapon of math destruction. Step 1, identify the stakes. Ask, could this model affect someone's freedom, income, housing, education, healthcare, or reputation? If yes, treat it as high stakes. High stakes require transparency and oversight. Step 2, check for opacity. Can you understand the inputs? Can you see your own data? Can you challenge errors? Is there an appeal process? If you can't see it and can't contest it, the system is already dangerous. Step 3, look for proxies. Ask, what is the model using instead of the thing it claims to measure? If it's using zip code, credit score, browsing behavior, social connections, or past risk labels, ask how those proxies might encode inequality. Step 4, search for feedback loops. Does the model's output change how the world behaves? Does it create the very data it later uses to justify itself? If yes, it needs careful design and independent evaluation. Step 5, demand outcome-based audits. Don't accept it's accurate. Ask, accurate for whom? Does it increase false positives for certain groups? Does it systematically deny opportunities to people who would succeed? Does it create churn and instability? If an institution won't track these outcomes, that's a governance failure. Step 6, create friction where it matters. This is practical. If you're a manager, don't fully automate hiring. If you're in education, Don't reduce teaching quality to a single score. If you're in policy, don't deploy predictive systems without public reporting and third party review. And if you're an individual, push decisions to humans when possible. Ask for explanations. Correct your data. Appeal. Escalate. This is the part most people skip. They assume they're powerless. But even small friction can force transparency, and transparency is where accountability begins. Now let's compress everything into a simple recap you can actually remember. 3-step compressed recap. 1. If a model is opaque, scaled, and harmful, it's not just an algorithm. It's a weapon. 2. Watch for proxies and feedback loops. They turn bias into data and predictions into destiny. 3. Demand accountability through outcomes, not intentions, not accuracy claims. Real-world impact. Weapons of Math Destruction is one of those books that changes how you see modern life. After you read it, a lot of neutral systems start looking like political choices made with spreadsheets. If you want the full book, it's linked below. And if you want more clear, practical breakdowns from the running library, consider subscribing. If you want the full book, it's linked below. Subscribe for more book insights you can actually use.